The Central Research Radio Engineering Institute, named after academician A.I. Berg, part of the Almaz Anti-Group, has unveiled information at the Aero India International Air Show on a new L-203 Gardenia 2 container active jamming station designed to protect aircraft from air-to-air and surface-to-air missiles, a TASS correspondent reported from the event. The information on the new jammer is presented at the Almaz Anti-display stand at the Aero India International Air Show. The Gardenia 2 container acting jamming station is designed for individual, mutual and group protection of aircraft by interfering with airborne and ground-based radars and radar stations, the presentation materials say. The new jammer can be adapted to modern aircraft, including foreign-made airplanes. The Gardenia is mounted on 2 aircraft hardpoints. Its advanced information interaction tools allow the jammer to be adapted to radio-electronic equipment of various frontline aircraft, Almaz Anti said. The Central Research Radio Engineering Institute, named academician A.I. Berg, has also showcased an MSP-418K compact jamming station intended for individual protection of MiG-29 and MiG-35 fighter jets. The jammer is presented on foreign markets thanks to its unique performance characteristics and protection efficiency. The jamming station is designed to generate individual reciprocal active interference to radio-electronic weapon controls of anti-aircraft missile, surface-to-air artillery and aircraft missile systems and knock them out of operation. Earlier, on December 12, the Russian Defense Ministry reported that a Su-35 fighter had been deployed to destroy a Ukrainian radar station near the hotly contested Kupiansk region, after the fighter detected the target using onboard sensors. The kind of radar installation was not confirmed. While on a mission to patrol the airspace in the Special Military Operation Zone, the pilot detected enemy radar emission in the Kupiansk area. Radar emission from the target disappeared as he launched a guided missile from his aircraft, it reported. Reconnaissance subsequently confirmed the target's destruction. The Su-35's formidable ability to conduct electronic attacks has made it highly capable in air defense suppression roles, with use of electronic warfare pods such as the Keiny ECM supplemented not only by the formidable electronic warfare capabilities of the fighter's primary radar, the Airbus-E, but also by 2 L-band AESA radars, operating in the 1.0 GHz to 2.0 GHz region of the radio spectrum, in its wing routes. This unique combination of sensors provides further options for electronic attacks on enemy assets. The Airbus-E's electronic warfare capabilities are nevertheless considered less advanced than those of top-end Chinese and American fighters such as the J-20's Type 1475, KLJ-5, and the F-35's APG-81. Keiny is an electronic countermeasures (ECM) system that has been specifically designed and developed for the Sukhoi fighter jets of the Russian Aerospace Forces. As the name suggests, this system is used to interfere with radio waves and to counter and deflect the enemy's tracking systems. The advanced Keiny ECM is usually in the form of 2 cylindrical pods that are mounted on the wingtips of the fighter jet, or in some models, 2 pods on the wingtips and 1 pod under the belly of the fighter jet, providing protection for the aircraft against threats. This system, after detecting a missile attack, creates a radio-electronic protective layer around the fighter jet, preventing the hostile missile from reaching its target and deflecting it from its course. The history of this system's development dates back to the Soviet Union era and the Kaluga Research Radio Engineering Institute. In Russia, the main companies involved in the design and production of airborne electronic warfare systems are known as Concern Radio Electronic Technologies, CRET in the Russian abbreviation. One of the most well-known and active companies responsible for the design of many of Russia's current electronic warfare (EU) systems is the Kaluga Research Institute of Radio Engineering, KNIRTI. This institute produces a complete range of airborne electronic warfare systems, all derived from a common baseline, platform, and produced in various variants to suit the country's fighter aircraft. This platform is referred to as Keiny, the name of a mountain range in Russia, in Russian literature. The initial design and development of Keiny electronic countermeasures system took place from 1977 to 1990. In 1995, the first successful operational test of Keiny electronic countermeasures system was conducted, and a second test was passed in 1997. Finally, in 2014, the Keiny ECM was officially unveiled and put into operation on the Sukhoi 34, which was the main platform for the development of this pod. According to Russian media outlets, the unveiling and completing of Keiny U significantly improved the electronic countermeasures system's capabilities against enemy radars. The electronic countermeasures system greatly enhances the stealth capabilities of the Russian Aerospace Forces fighter jets, making them highly resistant to NATO air defense systems for a wide range of operations. In the development of Keiny U, the prototype versions were tested in Syria, utilizing the experience gained from the Syrian conflict. However, the real-world experience of the Ukraine war and field testing under more challenging conditions will provide even better opportunities to further improve and refine this system.